Good day, great minds. Happy new week. Welcome to this wonderful session. And always remember that you are smart, talented, and a gifted child. Do have a great learning experience.
Class, I'll be taking vectors. You remember in our previous class where I taught measurements and units, we talked about the physical quantities, which includes the fundamental quantities, the derived quantities, and the supplementary or the pseudo-dimensionless quantities. Today, we'll be looking at what we call vectors. Over to the vectors, we are talking about the quantities that has either magnitude or has magnitude and direction. So we start with the scalars. Scalars are those physical quantities that has only magnitude or size. And examples of these quantities can be mass of a body, temperature of your body. It does not have any direction, rather it just have size. For instance, 24 degrees Celsius. Okay, volume, density, they are all scalars. Why vectors? Why the vectors are those physical quantities that has both magnitude and direction. And some examples can be displacement, velocity, acceleration, force, okay, even electric field, magnetic field, all are examples of vectors. Let's move over to the resolution of vectors. Vectors can be resolved in two different ways, either in the horizontal component or in the vertical component. So we have here as the vertical component, we have here as the horizontal component. Let's say this vector is attached to a direction theta, okay, and this is the resultant, okay. If we resolve this to the horizontal, that means closing it, we are going to have it to be what? Cos theta. If you resolve it to the vertical, we are going to have it as sine theta. That is to say, the r of the horizontal component is going to be r cos theta, while that of the vertical component will be r sine theta. In this case, we are asked for the resultant of this vector. The resultant is now going to be the square root of the squares of the horizontal plus the squares of the what? Of the vertical. And if you are asked to determine the direction of this vector, theta is going to be tan inverse of the vertical to the what? Horizontal. Next is addition of vectors. We can add vectors in three different ways. We can add vectors in three different ways. Number one is what we call the component method. Or we can also call it the vectorial method. Number two is what we call the graphical method. While thirdly, we have the parallelogram method. Okay, the parallelogram method. So in today's class, I will be taking the component or the vectorial method. The component or the vectorial method is a method of addition of vectors that shows the direction of the vectors. Now, in this case, we are going to take the vectors in two different dimensions. That is, in its x component and its y component. For this case, I'm going to take the example 1 to portray my points. So let's start with the example 1. From the example 1, we are asked, we are given that a lady drove her car north-west for a distance of 10 kilometers. And for your secondary school knowledge, you remember in geography that this point is north, this is south, this is west, while this is east. So when somebody walks northwest, northwest, this is going to be the direction of northwest. Is that not true? So here already is 90 degrees. Here again is 90 degrees. Half of 90 is what? 45 degrees. So we add 90 plus 45, you are going to have 135 degrees. So in that case, we resolve. So we resolve in the horizontal component and the vertical component. Okay, so let's start. So in this case, we're having a northwest for a distance of 10 kilometers. So northwest is 135 degrees. How did I get that? Here is 0, here is 90, here is 180, while here is 270 degrees. So we are going to have 10 cos 135 and 10 sine 135 degrees. Next, then east for 40 kilometers. So when somebody walks to the east, at what angle is that? 0 degrees. So she went 40 kilometers, 40 cos 0 degree, 40 sine 0 degree. And then south for 60 kilometers. So what's the direction of south here? 270 degrees. Good. So we are going to have 60 cos 270 and 60 sine 270 degrees. The question now is to calculate the overall displacement of the car from this starting point. So you take addition of the vectors. So we are going to add that. You bring out your calculator, then you start 10 cos 135 plus 40 cos 0, which is 1. So plus 40 plus 60 cos 270, 60 cos 270. And that is going to give us 32.9289 in I components. Then we are going to go to 10 sine 135 plus sine 0 is 0. So 40 sine 0 is 0 plus 60 sine 270. And we are having minus 52.9289 in J component. Okay, so next is for us to determine the displacement, the overall displacement. So the displacement is simply what? The resultant of x squared plus r of y squared. And that will now be giving us 32.928i squared plus minus 52.9289j squared. Now remember, when you're taking the spirit of same direction, you are going to have 1. So I squared is 1, which is equal to j squared, which is 1, which is equal to k squared, to the 1 also. So in this case, we'll take 32 squared plus 32.9289 squared plus 52 minus 52 plus that squared. So we are going to have the square root of 3885.784, and when you take the square root, the root of that, we are getting 62.33 kilometers. And that is the displacement in size, as in a magnitude. Now let's go and get the direction. The direction theta is going to be tan inverse of what? Of ry to rx. And that will now be giving us the tan inverse of ry is 52.9289 by 32.9289. So when you take that out, we are going to have 52.9289 divided by 32.9289, and that will be giving us shift tan of this answer. We have 58.11 degrees. Now the point is that you don't know the direction of this degree, but you can easily determine that using your elementary school number line. So here, this is the x-axis, the horizontal. Here is positive, here is negative. Positive x, negative x. Here is positive y, here is negative y. So let's go. The x component is what? Positive. You go and mark it. While the y component is what? Negative. You mark it. Remember, this is north, this is south, this is west, while this is east. So it fell in this what? In this quadrant. And what is that? This is south of east, or the east of the south pole. Now we are going to determine which using the angle given. Okay? Alright. Now, from what we have here, we are going to start here we will start from the South Pole and move. Since these have crossed the angle, we're having 58.1 is in the East Pole. Is in the what? East Pole. So that becomes 58.1 East. It's attached to what? The South. So the angle now becomes 58.1 degrees south of what pole? Of the East Pole. And that becomes the direction. Okay, so to portray more understanding, I'll be looking at the second question. Okay, so the second question says that a particle, okay, please go through that while I move on. All right, so the second question states that a particle is subjected to two displacements. A particle is subjected to two displacements as follows: 30 meters to the northeast. So like I did before in the first question, this is north, this is our south, this is west, while this is what? East. So where will be northeast? Northeast. It fell on this angle. Okay, so this is 45 degrees. Can you see that? 45 degrees. So you take it in the components, using the components method. Here we have the horizontal, we have the vertical. Okay, so going with that, we are now going to start 30 meters to the northeast, meaning 30 cos 45, 30 sine 45, and 40 meters to the northwest. This is northwest. So here again, 90, here 45, 135. So we have 40 cos 135, 40 sine 135. What must be the third displacement? We don't know the third displacement. Let's just call it x of the third, y of the third leg. If she is to end up at the starting point, now this is where it gets interesting. If you are to end up at your starting point, let's say I began this journey at this point, I moved, I got to the edge, then I came back. Let's say my movement from here to here took me a distance of 5 meters. Coming back is going to also be another 5 meters. Okay, so the displacement is going to be 5 minus 5, giving me what? 0. So anytime you start a journey from a point and your end point is back to that starting point, your displacement is going to be 0. So in that case, the overall displacement is 0 in the question. So how do we now get the third leg? Simple addition like I did before. So we are going to have here that 30 cos 45 plus 40 cos 135 plus x3 is equal to 0. Okay, so we add it up. So therefore our x3 becomes, so you take it down, you have 30 cos 45 plus 40 cos 135, giving us minus 7.071. So when it crosses equal, it changes to plus 7.0711. Next, we go to the y direction. So here we have 30 sine 45. So we have here 30 sine 45 plus 40 sine 135 plus y3 to be equal to 0. Okay, so you add it up, you have this moves over to this side while you have your y3, and you have your y3 to be equal to 30 sine 45 plus 40 sine 135, giving us plus 49. So when it crosses equal, it changes to minus 49.497. Okay, next is the resultant. So the resultant of this given vector for the third leg, R3, will be the root of x3 squared plus y3 squared. And that will be giving us the square root of, remember this is I and this is J component, square root of 7.07111 squared in I component plus minus 49.497 in J component or squared. So that when you take those square roots, you are going to now get, using the calculator, we have 7.0711 squared plus 49 plus 497 squared. Okay, and that gives us the square root of 2499.9534. Check the square roots, you have 49.999, which is approximately 50 meters. So this is the displacement of the third leg. Next, we need to determine the direction. Next, we need to determine the direction. The direction theta of the third leg will be the tan inverse of the vertical of the third leg, horizontal of the third leg, meaning the tan inverse of 49.4974 by 7.0711, which is going to give us this divide me by 49.4974 divided by 7.0711. Then we take your shift time of this answer, giving us what? 81.869 degrees. Okay, now we've gotten the angle, but we've not gotten the direction. Next, you check this out. Negative, positive x, negative x, positive y, negative what? Y. So where does this fall in? Negative y this side, positive x this side. Here is what? Here is east, here is what? South. So that becomes 81.86 east of the South Pole. Let me write it, east of the South Pole. And that becomes what? The direction. And finally, we are asked in this question to determine the magnitude of these given vectors. All right, so I'm going to write it out like a layman. So in this question, you are given that number 3, that vector A is equals to 5i minus 2k in meter. This means 5i plus 0j minus 2k, while b is equals to minus 3i plus 4j plus 6k. Now if you're asked to determine the magnitude of a vector, the magnitude of the vector is simply magnitude of a and b, which is the square root of a plus b with its what? Same component. So we start 5i plus minus 3i, giving us what? 2i all squared plus 0j minus what? 4j. That'll give us what? Minus 4j plus minus 2k plus 6k. That'll give us what? Plus 4k all squared. So by the time you take the square root, 2 squared will give you 4 plus 4 squared 16 plus 4 squared 16. That will be giving us the square root of what? 36, which is 6. They are all in meters. 6 meters. This is the magnitude of this given vector. So thank you this class. Thank you students. This rounds up this class. So please, I'm inviting you all to our physical class at kinematics tutorials located in Uniben Bangate, University of Benin, Edo States in Benin City. So please, I invite you all, and also subscribe to this channel so that you can be seeing our next class updates, kinematics. We'll be taking both O-level physics, chemistry, biology, mathematics, science classes, and also A-level, advanced level physics for both undergraduate students and master's level. Thank you.